Okay, we're looking at, this is now day 2 of the SAS4 worksheet. And we've actually already done number 6. We did that, actually I did this work over on number 3. Remember, it was your present value equals the future value divided by 1 plus I over n to the nt power. Okay, where I is your interest rate, n is how many times you're compounding, t is the years, future value, and present value. And he wants to, so our future value is 1,000. That's what Blaine wants to have, $1,000 10 years from now. So our future value is 1,000 here. So what you're going to do is, you've got 3 situations here. You've got 3% compounded quarterly, you've got 1% compounded monthly, or you've got 4.5% compounded semi-annually, meaning 2 times a year. N is equal to 2 for that one. All right. So rewrite this present day formula, this formula, down here. You're going to rewrite it 3 times. Make sure that you include the compounding periods other than annual. Incorporate the different rates. All right. So get that done. I'll wait. In fact, you can pause the video and then we'll come back to it. Okay. When you graph these on Desmos, what you're going to do is you're just going to write an expression. It's going to be y equals your future value. You're going to use that formula from the previous page. Your future value, you know, is $1,000. It's going to be y1 plus whatever your I value for each of those. You know, there's 3 different ones. You're going to have 3 different equations here. They're all going to be y equals. And you know, each time you finish one off, you go to the next. 1 over I over n, whatever, you know, depending on the 3 situations, I will change, n will change. And then up here you'll have n times, and you're going to use x instead of t. I and n will be numbers depending on what the situation is. You don't need to put subscripts by the y or the x in this particular case to match them up with a table, so that should be fine. Once you've done that, what you want to look at is which is changing things more. Is it the interest rate that seems to be more important, or the compounding periods? Okay, you're going to have 3. You're going to end up with getting 3 curves. When you set your window on this, you might set your x value from 0 to 10, and you might set your y value, you know, max it out at around, in fact, let's go a little bit above 1,000, let's say 1,100, and then 0. But you'll be able to see them. They'll be up toward the top of your screen, and you'll see those lines, and they'll look pretty straight. They're actually going to be curved, but you won't see a whole lot of curve to them in 10 years. If you looked at it over a longer period of time, you probably see more curve. But over 10 years, you're not going to see a whole lot of curve. And you really, what you would like is the bottom line, because that bottom curve, that bottom line represents less money for you to pay now, or for whoever this was, for Blaine to pay now, so that in 10 years he'll have $1,000. So best for him will be that bottom line, because that represents less money for him to put down now, so that he'll have $1,000 in 10 years. So look at which of these 3 equations, look at which one is going to be best for him. Okay? And then that's going to help you answer number 9, and which account should Blaine invest and why. Alright, if you have questions about that, I might not have been super clear there, I tried to be, but if you have questions, please send me a note, and if I need to clarify this more in the future, I will do that. Okay? Bye-bye.